Welcome back, everyone. Our topic today is probabilistic reasoning over time. We'll start by introducing time into our current BaseNet models. Then we'll talk about two specific types of BaseNets that allow us to deal with time. We'll talk about Markov chains and we'll introduce hidden Markov models. So far, we have dealt with uncertainty in a static world. In our treasure hunt homework, the treasure does not move while we are looking for it. In practice, the world changes over time, and we only observe part of it. We need to be able to track it and predict it. So often, we want to reason about a sequence of observations. Examples include robot localization, medical monitoring, and speech recognition. For example, in robot localization, we have a moving robot, and we need to figure out where the robot is at any given time. The robot has sensors, and every so often we get a reading from these sensors. The sensor readings may still be noisy, just like in our homework, but here the robot is also moving. So we need to put together a sequence of these noisy readings and add to it what we know about the world, how the robot can move, to infer the position of the robot at any point in time. So in general, we have some underlying state that we don't get to observe. We have some observations connected to the state, and these observations are chained together over time. So we need some mechanism to be able to reason over time with the uncertainty that we have seen before. We need to add time slices to our model. We'll look at the world as a series of snapshots or time slices. So the basic idea here is that we have a set of state random variables for each time step t. The variable xt represents the state of the world at time t. These random variables may be observable or unobservable. This, of course, assumes that we have discrete time. We've learned that BaseNets are great at representing probabilistic models. So how do we construct a BaseNet here? The first thing to do is to create a node for each state random variable. This is the easy part. The trickier part is where do we put the arcs? Do we need an arc from x1 to x2? An arc from x1 to x3? An arc from x1 to xt? We could end up with a very complex BaseNet if we do that. Luckily, we can always make assumptions to simplify our models. So the Markov assumption is the assumption that xt depends only on a subset of its predecessors. The first order Markov assumption goes even further. We assume that state xt only depends on the previous state xt minus 1. So xt is independent of x1, x2 up to x of t minus 2 given xt minus 1. And this is another way to write the same thing. And now with this first order Markov assumption, we can easily place our arcs. And we have a causal chain here. So another way to look at this Markov assumption is that the future and the past are independent given the present.